Welcome to second part of this lesson for week 3. We'll talk about covalent bond in this. Let's define covalent bond. The bond is formed by mutual sharing of electrons is called as covalent bond. In this covalent bond, there is no loss and no gain of electron is involved. And if there is no loss and no gain of electron involved, it means there is no formation of ions taking place. So we will not draw any ions in this case. We'll just draw the last shell and showing the mutual sharing of electrons between the atoms. So for drawing the dot and cross structures of covalent compounds, we'll just draw the last shell and indicating the mutual sharing of electrons. Please remember the covalent bond is formed between nonmetals and nonmetals. Types of covalent bonds. Let's talk about single covalent bond. If one pair of electron is shared between two atoms, this is called as single covalent bond. One pair of electrons shared between two atoms. Let's talk about an example for that. HCl, formation of an HCl. Hydrogen belongs to group 1A, chlorine belongs to group 7A. Both are non-metals. So it is a bonding that is taking place between non-metal and non-metal. So it is a covalent bond. The very first thing you should do you should calculate in your mind. So hydrogen is going to complete its duplet by sharing the last electron of chlorine, and at the same time chlorine is going to complete its octet by sharing the last electron of hydrogen, and this shared pair of electron is held between HCl and is shown as a single line. So a single covalent bond is shown by a single straight line between H and Cl, HCl. Let's talk about chlorine molecule, formation of chlorine molecule. Both chlorine shared the last pair, the last electron, completing in their octet. Each chlorine will complete its octets, thus showing the formation of Cl2 molecule. Let's talk about double covalent bond. In double covalent bond, we have that is defined as sharing of two pair of electrons between two atoms. That is called as double covalent bond. The common example is for oxygen. Oxygen belongs to group 6A, and if it belongs to 6A, it means it has 6 electrons of its own in last shell and needs 2 more electrons to complete its octet. So to gain these 2 electrons, each oxygen molecule will preferably go for sharing among themselves. So the sharing of electron will take place, the last shell will overlap with one another, and 2 pairs of electrons will be shared between 2 oxygen molecules. So after sharing, you can just count that if the octet of each oxygen has been completed in the last shell. Yes, you can go and count for both the oxygen atoms, the octet of each of oxygen has been completed. You can go and you can count by the end 1 2 3 4 5 6 7 8 for the right side oxygen and on left side as well. Both are held together by a double covalent bond shown by 2 straight lines between oxygen atom. Okay, let's come to the second example, that is carbon dioxide. Formation of carbon dioxide, that involves carbon and oxygen. Both, once again, the atoms involved are non-metals. So it is once again a covalent bond that is going to be formed. Now we will once again do our mind calculations for the how many electrons are going to be shared. For carbon, if we note that it belongs to group 4A, if it belongs to 4A, it means it has 4 electrons of its own. Oxygen belongs to 6A, so oxygen has 6 electrons of its own. So carbon needs 4 more electrons. 4 electrons are of its own and 4 more needs to be gained to complete its octet. So carbon atom will come in center because carbon is going to share more number of electrons, whereas oxygen belongs to 6 A and it has 6 electrons of its own and just need 2 more to be shared. Oxygen will come on a side. So to draw the structure of carbon dioxide, let's draw the electrons of carbon first. 4 electrons of carbon orient themselves in such a way on sides, and on each side oxygen will be there, and 6 electrons, 1 2 3 4 5 and 6 will be drawn. 5 and 6 will be shared with the 1 and 2 of carbon. Similarly for the other oxygen, 5 and 6 will be shared with 3 and 4 fourth electron of carbon. By the end of this whole sharing, if we count, for each oxygen the octet is complete. 1 2 3 4 5 6 7 8. The shared pair of electrons will be counted for oxygen as well as for carbon. So if we count for carbon them as well, 2 pairs on one side and 2 on other side, making 8 electrons complete. And similarly for left side oxygen, 8 octet is complete. So after drawing the structure, you also need to recheck by counting the electrons for each element that whether octet has been completed or not. We will represent the formation of these double bonds between carbon and oxygen as two double lines, two straight lines on both sides of carbon showing double bond. Let's talk about ethene. The formula for ethene is C2H4. Now it means we will first once again go for analysis that carbon belongs to group 4A, 4 electrons need each carbon, and hydrogen needs 1 more electron to complete its duplet. So how the sharing will take place, each hydrogen will be sharing 1 electron of carbon to complete their duplets, whereas 2 pairs of electrons will be shared among carbon. So after sharing 4 electrons of each carbon with 4 hydrogens, this is how the formation of ethene is taking place. If we will be counting electrons for each hydrogen and carbon. Hydrogens will be completing duplet, carbons will be completing octet after sharing the electrons. Okay, let's talk about triple covalent bond. Triple covalent bond is defined as 3 pairs of electrons shared between 2 atoms. 3 pairs of electrons are when shared between 2 atoms. This is triple covalent bond. One of the most common example is bonding between nitrogen and nitrogen, formation of N2 molecules. Each nitrogen belongs to group 5A. So if it belongs to 5A, it means it has 5 electrons of its own and needs to gain or share 3 more electrons to form 8 electrons. So this sharing of 3 electron will be taking place between both the nitrogens. Nitrogen will orient its electron in such a way that 3 electrons will be facing towards the other nitrogen, and these 3 the other will also be and the 2 will be left unpaired. 3 electrons are drawn on one side and the other nitrogen will also be coming with its 3 electrons and sharing, both of the nitrogen will be sharing 3 pairs of electrons among themselves, and 2 electrons will be left unshared on each nitrogen, as also shown in this illustration in front of you. So 3 pairs are shared in total between 2 nitrogen atoms. You can just count down. After sharing these 3 pairs and the two lone and the two which are left unshared, you can count octet of each nitrogen is complete. Let's move to now the next topic, that is polar and non-polar covalent bond. A non-polar covalent bond is formed between two similar atoms when there is no electronegativity difference. For example, chlorine molecule. Chlorine is formed between two chlorine atoms sharing the last electron, and as a result of this sharing, octet of each chlorine is completed. But as both chlorines, they are having no electronegativity difference, so the shared pair is held equally together between two chlorine atoms. Okay. Whereas a polar covalent bond is formed when two different atoms are involved in bonding with an electronegativity difference. For example, HCl. Hydrogen belongs to group 1A, so it is an electropositive element. Chlorine belongs to group 7A. It is electronegative in nature. And you can go back for electronegativity to chapter number 3. In last lesson we talked about. Due to the more strong electronegative power of chlorine, this shared pair of electron is more attracted towards chlorine atom. So this is not equally held. This strong sharing actually makes it a polar bond. Let's understand this with the help of this illustration. Non-polar covalent bond, there is equal sharing of electrons, whereas in polar covalent bond there is an unequal sharing of electrons and there is formation of partial positive and partial negative ion. Partial negative ion is formed because of more electronegative nature, just like as shown in this example, chlorine. It becomes partial negative due to its more electronegativity, and it pulls the shared pair more towards itself as compared to the other. Whereas in ionic bond there is no sharing of electrons involved. Let's have another comparison of ionic and polar covalent bonds and non-polar in this illustration. Ionic bonds, we have complete ions, means positive and negative charges are formed, cations and anions, and electrostatic forces are holding them together, for example NaCl. Whereas in polar covalent bond there is unequal sharing of electrons and slight negative and slight positive, means partial positive and partial negative charges are formed. By partial positive and partial negative, partial positive is for more electropositive atom and partial negative is for more electronegative atom, and this partial means half positive. So in difference to ionic bond were having complete positive negative ions and cations, whereas in polar we have partial positive and partial negative charges. They are not complete, and this results in unequal attraction or sharing of electrons, means electron pair is unequally held. Whereas in non-polar covalent bond we have equal sharing of electrons and the charges are balanced among atoms. For example, carbon dioxide, very less electronegativity difference is there between carbon and oxygen, so the carbon oxygen bond is non-polar. All right, let's talk about another type of bonding, that is coordinate covalent bond or dative covalent bond. This is also included in your syllabus contents according to FBISC syllabus outline. So you have to go through this topic as well. You have to learn the definition with one example. That is more than enough for you people at this stage. So this covalent bond is different because in this covalent bond one atom donates a pair of electron and the other atom is not at all involved in any contribution. So only one atom is involved in donating a lone pair of electron. This is called coordinate covalent bond. One of the example is formation of O3 molecule. O2, this is when this formation takes place when an O2 molecule adds up another oxygen. O2 we have previously discussed. So the O2 actually adds up another oxygen by sharing one of the oxygen, donates its lone pair to the third oxygen, and as a result they form a coordinate covalent bond. The third oxygen does not contribute anything in bonding, but still it completes its octet by getting an electron from the second oxygen. One of the good example is another example given to you, formation of ammonium ion. Ammonia, if we look at the structure of ammonia, it has a lone pair of electron on it, whereas the rest of the three pairs are shared. This lone pair is donated to when it comes close to electron deficient hydrogen. This lone pair is donated to this electron deficient hydrogen, and as a result the electron deficient hydrogen completes its duplet, whereas forming a coordinate covalent bond. This lone pair is donated, the illustration, lower illustration is indicating you, and as a result and a duct is formed, a structure shown in bracket. Let me show you the representation of coordinate covalent bond. Coordinate covalent bond is represented by an arrow ahead pointing towards electron acceptor, electron pair acceptor, whereas all other covalent bonds of nitrogen hydrogen are represented as single lines, whereas coordinate covalent bond is shown as an arrow ahead pointing from electron pair donor to electron pair acceptor. So this is how the representation of coordinate covalent bond is shown, that it is pointing an arrow from electron pair donor, that is nitrogen, to electron pair acceptor, that is hydrogen. Let's move to the last topic of this lesson, metallic bonds. Metallic bonds are present in metal atoms, and these are due to the presence of mobile electrons in metals. As we know that metals have large structures, atomic structures having positive charge concentrated in the center, surrounded by a sea of electrons, and this sea of electron actually contributes towards certain properties, that is malleability, ductility, and high densities. Let's have a quick recap now. We talked about in this lesson we talked about the stability of atoms, how they want to attain noble gas electronic configuration, and why and how this is done. Then we talked about chemical bonds, which involve complete transfer of electrons, mutual sharing of electrons, and coordinate covalent bond as well. We discussed that metals have tendency to lose electrons, they form cations. Non-metals have tendency to gain electrons, they form anions. Then we discussed ionic bonding, that strong electrostatic forces holds together, and this gives ionic compounds certain properties like high melting points, boiling points, and covalent bonds. We also talked about that they are weak than ionic bonds. Then we have ionic bonds. They are the covalent bonds. They are formed between similar atoms. They are nonpolar, and the covalent bonds formed between different atoms, they are polar in nature. Then we discussed that in covalent bonding there are three different types: single, double, and triple covalent bonds. We also talked about coordinate covalent bond formed between electron pair donors and electron pair acceptors. And lastly, we discussed about the metallic bonds, how the presence of sea of electron actually contributes towards the characteristic properties of malleability, ductility, high densities of metals. With this, we end our week 3 lesson, and there are some written tasks associated with it. You may find them in assignment section, and there are some additional resources given to you. You may find them in resource section, and hopefully I hope so you people will practice a lot for dot and cross structures. So for now it's that's all. Have a nice day and good luck. Thanks.